Hello, physics. This is my second attempt at this video. Apparently, the video file got corrupted the first time. So this is the video over the quizzes. I am going to make this available, but I will, unlike the others, I'm going to take this one down eventually because I don't want the video with the answers to my quizzes floating around out there. So this will be available for a while, definitely through the next week, and then I will probably pull it down off YouTube. So just so that you are aware of that. So I'm going to, I just want to record a little intro before I got started. I'm going to try and go through these as quick as possible so that this video does not get super long. I'm going to do all 4 quizzes, so all 8 problems. And the first couple should go pretty quick. But the third and fourth ones might take a while. That's why I'm trying to move these pretty quick. So that said, I'm going to pause this, write some information down, and we'll be good to go. All right. Oh, I forgot to pull. Sorry about that. Forgot to pull up the question so I could actually see it while I was doing this. All right, so consider the cannon discussed in the previous quiz, the one with a barrel 2.5 meters long and a muzzle velocity of 237.8 meters per second. When the cannon is fired, assuming a constant acceleration, what force is exerted on the 12-kilogram cannonball while it is in the barrel? Ignore friction. So our initial position is before, or where the ball is in the barrel before it is fired, and then the final position is going to be as it exits the barrel after it's fired. So our distance traveled is going to be the given s, the length of the barrel. The final velocity is the muzzle velocity. The initial velocity has to be 0 because until you actually light it and it goes off, the ball's not actually going anywhere. So in order to solve this, our force is going to be equal to the mass of the cannonball, or the force exerted on the cannonball is going to be equal to the mass of the cannonball times the acceleration that it experiences. So we need to use kinematics to get A, and then we can use the 12 times that A that we find to get our force. So in kinematics, we have VF, VI, and S. So kinematics equation 2, which is going to be VF squared equals VI squared plus 2AS. Solve that for A. VI is 0, so VI goes away. VF squared over 2S gives us A. So VF squared is 237.8, well, squared. And then over 2 times 2.5 would give us 5. So plug that into our calculator, we get out 11,309. But sig figs, we need to round to 3 digits. So 11,300 meters per second squared. Okay, then we plug this times 12 to get our force, and that's how we get our final answer, which you can see in the picture that I posted. So that's the first question. That's the cannon. So for the bucket question, an old-fashioned well has a bucket hanging from a pulley. If the filled bucket has a mass of 22.5 kilograms and is raised from rest, so VI equals 0, by 2.75 meters, that's our S, in 3.2 seconds, then what is the constant force being applied to raise it? So, once again, we have to find F, which is going to be equal to the mass times the acceleration it is experiencing. But in this case, we find that if we do a free body diagram, our force, this is our definition, I should say. Okay, so our sum of forces is equal to the mass times the acceleration. We have a tension force up, weight down, and from that we can determine we know that these two have to be equal. So, Ft, I should pause this and do this part. Just realized I was starting to do this in the wrong way, so I caught myself. What we can do is we can say that the upward force has to be equal to the mass times the acceleration it's experiencing. We can find the acceleration using kinematics, and then that will allow us to find our force. So we need to use the kinematics with equation 3, since we have Vi, S, and T. The only equation that will actually allow us to get our acceleration is going to be equation 3. Vi is 0, so the first part of equation 3 drops out. S is equal to AT squared over 2. So I will be back in just a second. So that worked out here. S is equal to AT squared over 2, which converts to 2S over T squared. Plug the numbers in, and we get that the acceleration is 0.537. Take that times our given mass of 22.5 kilograms, and that will give us our applied force here, or the tension force. So that is it for quiz 1, which brings us to quiz 2. First question, which was the bird feeder. So a bird feeder of mass 12 kilograms hangs from a tree by a single cable. I was nice. I only made it one cable. Okay, what is the tension in the cable? So if we draw this out, we've got weight pulling down, we have tension pulling up, and these are the only two forces we have to worry about. Don't mind my funky looking bird feeder here. The only number that we're given is the mass of the bird feeder, which is 12 kilograms. But we know that weight, or the force of gravity, is defined as mass times the acceleration of gravity, and the acceleration of gravity is a constant at 9.81 meters per second squared. So we write a sum of forces. It's not moving, so Ft has to be equal to Fg. Fg is m1g. So we plug in 12 for m, 9.81 for g, which has to be equal to not only Fg, but Ft. So the tension in the cable would be the product of those two numbers. And so now two masses over a string. Two masses are connected by a lead string over a frictionless pulley, as shown in the figure here. Mass 1 is 15 kilograms, and mass 2 is 5 kilograms. 3 sig figs in both those. Neglecting friction, determine the tension in the string and the acceleration of the system. So here's our diagram of what's going on. They gave us M1 and M2. And then I did a free body diagram of mass 1 here, noting that the acceleration is in the positive direction for M1 in x, and the acceleration for mass 2 is in the negative y direction. That's important later. And if you get yourself in the habit of doing this and noting A as you're drawing your free body diagrams, it will probably save you trouble in the long run. Okay, so writing our sum of forces, we have two equations for mass 1. In x, we have the tension force in the positive x direction and no negative force. There is no friction in this problem, so it's just the tension. So the tension is going to be equal to the mass times the acceleration, because it is accelerating. It's moving, it's accelerating. It's not moving at a constant speed. And we would never know if it was, by the way. If it is moving at a constant speed, in which case the acceleration would be 0, you would be told that in the problem. So that's worth noting. So that's x. In y, we have the positive normal force minus the negative gravitational force, or weight, which is going to be equal to 0 because it is not moving in this direction at all. It's sliding this way. Now, because there is no friction, we do not need this equation. And that is always going to be the case. If there is no friction, you can ignore the vertical equation or the vertical dimension for the problem, unless you're actually trying to find the normal force, in which case you will need that. But rarely am I going to ask you to find specifically the normal force, but I thought that might be worth throwing in there. I'm blanking. I just did this. So then we get to our second one. There is no motion of any kind in X. It's stationary. There's no forces in X. So we just have our Y equation. The upward tension minus the downward weight of 2, so is equal to negative m2a, because this is the second mass. Then we can manipulate these equations. Since one of them is already solved for Ft, we don't have to do much manipulation other than plugging in m1a for Ft in this equation, giving us this. Some algebraic manipulation, factoring out a, will give us that the acceleration is equal to m2g over the sum of the masses. Once we have the acceleration, we can plug that into a from our first equation to find Ft. Which brings us to quiz 3. Now, the first problem in quiz 3, I think, threw a bunch of you for a loop. Okay, and this is the truck slamming on its brakes and starting to slide. So I gave you the weight of the truck, and yes, it should have been 30,000, not 3,000. I apologize for that, because I know that caused at least one person some trouble. But 3,000 Newton weight, so that's Fg, gave you the velocity of 25 meters per second that it's driving. If it slams on its brakes and it's sliding until it stops, Vf has to be 0. And then I told you the coefficient of friction in the problem is going to be 0.68. So from there, we know that a truck is driving, and it does not matter what direction you say the truck is driving in. Okay? I did it driving this way, driving in the negative direction, because that made my force of friction positive, and it made the math a little easier, so I didn't have to deal with as many negatives. Made my force of friction positive, and the acceleration is positive, because if it's driving that way and slowing down, the acceleration is this way. Okay, the acceleration and the friction have to be in the same direction. So we have a negative velocity and a positive acceleration, which results in us slowing down. Then we have the normal force up, the gravitational force down, and that's pretty much it. So in X, the force of friction, positive force of friction, which is weird, I know, but you get used to it, is equal to the positive mass times acceleration, or the mass times the positive acceleration. In Y, the normal force minus the weight is equal to 0, which means that the normal force is equal to the weight. We know that friction is defined as the normal force times the coefficient of friction. Now, a couple of you have gotten a little confused on this. The coefficient of friction is not the same as the force of friction. The coefficient of friction is the ratio of how quickly two materials rubbing against each other are going to cause themselves to slow down. Okay? But it is not the same thing as the force of friction. Now, something I can do is tell you that the coefficient of friction is 0. If the coefficient of friction is 0, then that means that the force of friction has to be 0, because no matter what the normal force is, we're going to multiply it times 0. So if the coefficient of friction is 0, then that means there is no friction in the problem, which is something I did in quiz 4 in an attempt to make it easier, but I think I ended up confusing a couple of you. But I do that on the test, so I want to make sure that you understand that. Now, we do a little equation manipulation, so I'm going to pause this again. And I realize that I have not actually pointed out how we know what we're trying to do here. Now, because I'm asking for how far we went, that means that we are talking about a kinematics problem. Okay? Otherwise, you wouldn't have distance and velocity. So what we have to do is the reverse of the last quiz. I'm giving you enough information to solve for the acceleration, because we can manipulate these. We know that the force of friction is equal to the mass times the acceleration. The definition of friction is the normal force times the coefficient of friction, and our Y equation tells us that the normal force is equal to Fg. So plugging all three of these in together, Fg for Fn and Fn mu for Ff, we get that Fg times mu is equal to the mass times the acceleration. So if we take Fg mu divided by m, that will give us our acceleration. And then, after we have done that, we have two options in kinematics to get S. Okay? We can go to equation 1, because we know Vf, we know Vi, and we now know A. We want S. We could use equation 1 to find T, and then plug T in to equation 3, which is already solved for S. And some people would prefer that option. Considering that Vi is not 0, I'm not inclined to take that option. My inclination instead is to use equation 2 and just solve that for S, because we already know Vf is 0, we know Vi is 25, and then we get A from our kinematics, from our sum of forces. So that is how you're going to solve the truck problem. Now, one thing I need to point out here, whenever you go back and forth between forces and kinematics, direction for acceleration, you have to manually keep track of. Okay? For example, here, your acceleration is not negative. Okay? But your direction, and so you're going to get a negative answer. Well, that's because the way I set this up, I'm traveling in a negative direction. So my displacement would be negative. Okay? And that's why I asked, how far will I slide? I didn't ask specifically for a vector version. You can just give me the distance. You don't have to give me a sign on this. If I ask specifically for displacement, then I would need to tell you which direction you were going. But I didn't tell you which direction we were going in this problem to start off with. Okay, so I wanted to mention that. Next, we have the two masses problem for this quiz. Now, before I get going on this, something I feel that I should point out. And I think I've said this, but I want to reiterate it because we have the test coming up. You have to be able to write sum of forces equations based on the picture or description of what's going on. You cannot assume that you're going to find a sum of forces equation that works from a problem that we've done somewhere else. Okay? That is a big mistake I see people make in college physics all the time. They try to take old equations from different problems and use them. And that doesn't work out. There's a reason that there is no sum of forces equations on your note card. It's because they depend completely on the scenario. Now, yes, there are certain patterns, but if you try to force the wrong equation to work, you're going to end up not getting any points, because I'm going to look at it and go, where did this equation come from? This doesn't make any sense. So make sure you know why we have the sum of forces equations that we do. Now, for this one, it's the same diagram as before. So we have a negative vertical acceleration for mass 2 and a positive horizontal acceleration for mass 1. We're given both masses and our coefficient of friction. So here's our free body diagram for mass 1. Here's our free body diagram for mass 2. I've again noted the accelerations. Horizontal in mass 1, we have a positive tension force and a negative force of friction. It's moving in the x dimension and it has an acceleration. So we have to set it equal to the mass that is moving times the acceleration, so m1a. Vertically, we have the positive normal force and the negative gravitational force, so Fn minus the force of gravity is equal to 0 because it's not moving up or down. And then in y for mass 2, because there is no x component, we have the positive tension minus the negative gravity is equal to m2 times the negative acceleration, so negative m2a. Okay, now with some more equation manipulation, we get that Ft minus the normal force times the coefficient of friction, which is equal to the force of friction, is equal to m1a. Okay, we also find that with this one, the normal force has to be equal to the weight of the first mass. And I did go back and add the subscripts 1 and 2 here, because that's, kind of important. And I forgot to plug that in up here. I'll have to do that here in a second. Then this equation here, the tension force, I moved this over and plugged in mg for Fg2. So positive m2g, or Fg2, minus m2a. And I'm going to pause this and rewrite this, and I'm going to plug in Fg1, or m1g, for Fn here. So I'll be right back. Okay, so this would be this equation with m1g in for Fn. Okay, now we have this equation solved for Ft, so we can plug this in for Ft here, and then solve for A. So we can take, once we plug it in, we get m2g minus m2a, which is Ft, minus m1g mu equals m1a. Then we get the two terms, because we have 4 terms here. We take the 2 that have a in them, move them to the side where they're positive, because life is easier that way, and keep everything else on the other side. So m2g minus m1g mu equals m1a plus m2a. Factor out a, so it's the sum of the two masses. Divide by that sum. That will give us our a. Then we take a, plug it back into this equation to find Ft. And that's it for Q3. Which brings us to the last quiz, Q4. Now, this is the torus problem. So I only gave you 2 numbers in this problem. I gave you the angle of inclination of the hill, and I gave you the weight of the torus. So, torus is sitting on a hill. I'm using a box here instead of the car because this is a pain to draw. So, and a box will work just as well for what we're doing. So straight down, we have the weight. Okay? And then in what we are calling the positive x direction, which is up the hill, we have the force of friction, because the car would move down the hill, but friction is preventing that. Then we have normal force perpendicular to the surface of contact. And then our force of gravity, because it is straight down and we're using a tilted coordinate plane, is going to be acting in both the x dimension and the y dimension. So straight down would be the hypotenuse of our triangle. And I told you in our tilted video that the angle of inclination is always going to be between your old negative y and your new negative y. So old negative y would be straight down along FG. Should do it here. New negative y is opposite Fn. So this is new negative y, this is old negative y, and this has to be your vertical component. So if this is a vertical line, this is our horizontal line, and this is the hypotenuse. And I just crossed this out a little bit. So x is opposite, g is adjacent, y is adjacent, so y is cosine, x is sine. Our sum of forces equations, because it is not moving again, it is stationary, we have that the sum of forces for both will be equal to 0. Horizontally, we have the frictional force up the hill in the positive x direction, so frictional force is positive, and down the hill in the negative x direction, we have the horizontal component of the weight, okay, because this component of the weight is acting down the hill. In the vertical equation, we have the normal force up, and in the negative y direction, we have the y component of the weight. Okay, So then we get equation manipulation will tell us that the force of friction is equal to the horizontal component of the weight, and the normal force is equal to the vertical component of the weight. So with a little bit more equation manipulation, we find... Pause it, I didn't need to. We're looking for the force of friction. So we find that the force of friction is equal to Fgx, which is this right here, and that's it. That's all we have to do. Now, to do the bonus question, what we would have to do is, and now I'm going to actually pause it and do some stuff. So, plugging these 5 equations in, so this is the definition of friction, this is our y equation, this is our x equation. I'm going to use this as the base, the force of friction, which is equal to Fgx, which is Fg sine theta. So the force of friction is defined as the normal force, which is Fgy, which is Fg cosine theta. So this is the normal force times the coefficient of friction. We solve this for the coefficient of friction. We get Fg sine theta over Fg cosine theta. Fg divides out, and the sine of theta over the cosine of theta is the tangent of theta. So if you are a risk taker, then you would get, or you could determine mu by just taking the tangent of 18. So that's how you would do this one. So that leaves us with the one last problem that I did not give myself nearly enough space on my paper. So hopefully this time I plan a little better. Let's find out. All right, last question. This question was more difficult than I intended because this triangle is backwards. That is really what makes this problem difficult. Because since this is backwards, or since this triangle is oriented the way it is, part of the weight of your second mass is actually in the positive direction. So your weight is a positive force, which messes with people's heads. There will not be anything as difficult as this problem on your test. So take some solace in that, but I still think you should know how to do it. So, first off, I also gave you the weight of the dangling mass and the mass of the diagonal mass, which meant that in order to determine the acceleration, the direction that these were going in, you actually had to convert one of them to the other. So either convert Fg1, the weight, to the mass, or the mass of M2 to the weight. I decided to go M1 because having the mass is more useful than having the weight, because we can always sub in the mass times the acceleration of gravity to get the weight later. So since M2 is 50 and M1 is 36, M2 is heavier. And since there's no friction, that means that this system is going to go this way. Now, how do we know that there's no friction? Because I told you that the coefficient of friction was 0. When the coefficient of friction is 0, there is no friction. You ignore friction altogether. So that means this is going this way. So M2 is accelerating in the positive x direction, and M1 is accelerating in the positive y direction. So both accelerations are actually positive in this problem, which is nice, but at the same time becomes a little confusing later, because you always expect your acceleration to be negative. Now, here's our free body for mass 1. We have the tension up, the weight down. That one's pretty straightforward. Tension minus weight equals M1A. For mass 2, we have the tension in the negative x direction, and the horizontal component, the x down here, the x component in the positive x direction. So our horizontal weight is actually positive, and we subtract the tension. And of course, that's always equal to the mass times the acceleration, so m2a. In y, we have the same thing we usually do. Normal force positive, vertical component of the weight negative, so normal force minus the weight equals 0. So from here, we do a little bit of equation manipulation. Now without choking. All right, so first here I have taken this triangle and found our y component and our x component. Then I solved this equation for t and solved this equation for Fn, which I wrote, no, wait. I solved this equation for t, copied this equation over, and then Fn here. I also made a note that Fg2 is going to be equal to mass 2 times g. Now, since there is no friction, we do not need the normal force. And since we do not need the normal force, we do not need this equation either. And so these three equations then can be simplified down to these two equations. So Ft equals m1a minus Fg1. And then I plugged in Fg2 sine theta for Fg2x to get this equation. I also plugged in Fg2 over g for m2 here. So now, going forward, what we need to... Oh, you know what? I didn't need to do that. No, I'm going to cross this out now. Because I have M2. I don't have Fg2. So I'm going to rewrite M2 here. So now, going from here, I need to plug this in for Ft, which I'm going to probably do down here because I've got more space. And then solve for A. All right. Now, I caught something as I was going through this. And I went ahead and did a little more algebra on the second equation and moved Ft to the other side so that it would be positive, so that I would not have to distribute a negative sign when I sub stuff in. So that is why I went ahead and did this. So then I took this equation, rewrote it here, but I subbed in for Ft, F1a minus Fg1. Okay, then I algebraically solve for A, which gives me 6.5, which you might notice is different from the key that I posted. When I looked at your guys' answers, I realized that the answer I had didn't match anybody's, and I thought that seemed unlikely. So I am going to double check this as well and make certain. That's why you shouldn't rush through physics questions, if you were ever wondering. I rushed through it, and that's why I made this. That's why I made some stupid mistakes. I was also trying to pack it into a very small space, which you can probably also tell. So that gives you your A. Then you take your A, plug it back into this equation to get Ft. And that's it for this. I managed to get this video just a little bit under a half hour. That's it. I'm going to go ahead and stop here so I can upload this and get it to you. It's about 5 p.m. right now. I apologize for how late this is coming out, but at least I did get it to you today. Sorry about that.